Next, we're going to ask David Attaway to come up. He's a geological information scientist. He describes himself as a medical geographer. He does some really phenomenally interesting work, and he is with the Environmental Systems Research Institute.
Well, I guess I get to just present this way. Good afternoon, everyone. My name is David Attaway, and as Martin said, I'm a medical geographer. I work for ESRI as a solution engineer. So you may ask, well, why is a solution engineer up here talking to us about medical geography? For the last 7 years, I've actually been working on identifying mapping limitations, developing new spatial statistics, as well as identifying new methodologies that we can use to be able to monitor risk, as well as to be able to map new statistical analyses. So how many of you, ask a question to the audience, how many of you went to lunch this afternoon and used an application like Yelp? All right, a couple of you. So you may ask, well, maybe this thing is very beneficial for me. Maybe it guides me with being able to make my decision. But how does this really relate to medical geography? Well, what happens is that when we search for restaurants, behind the scenes, it's looking at all those locations, and all those locations are being ranked by some way or method. This could be based off of the review, it could be based off of the location, it could be based off of distance, but all those locations are being mapped. Same thing if we were to look for a specific thing like pizza. To where can we search behind the scenes, all those locations are being mapped, but why don't we do this with medical GIS? So the way we can actually use this is using an application or a statistic called cosine similarity. With ESRI, we've developed a tool called the Similarity Search, which provides us the ability to identify candidates or features that are most similar or dissimilar to a specific feature or attribute. So you may ask, David, well, what exactly does this mean? So what we're going to do is we're going to look at potential store locations. And so we have all these locations on the map, all these locations that we're trying to identify. But then we have this one high-performing store. So what we're going to do is we're going to search the geographic area and try to find, okay, where are the most similar locations on this whole map compared to this very high-performing store. So the way that we can actually do this is to, for each one of these attributes, we can compare and rank those locations. So all those locations on the map are being ranked compared to that high-performing store. In this case, we're looking at population density, average income, and distance to competition. So once we have that high-performing store, we can look at that whole geographic area and be able to identify, in this case, the 5 locations that are most similar, or the highest locations that are similar to that one high-performing store. But this same type of analysis we could use with medical geography. In this case, looking at dengue and being able to identify attributes based off of published literature, but at the same time also being able to perform a Z-transformation so we can compare apples to apples. And then run all these models in ArcGIS. So in this case, I focused on an area in Kenya where I had 167 cells of mosquito locations. I had 120 cells of where outbreaks had occurred between 1982 and 2013. And so I threw this into the Similarity Search tool. Took information such as elevation, population density, and bioclimatic variables, and provided an averages map which analyzed all those locations compared to those outbreak locations. At the same time, I took it a step further and did individual iterations of each specific point. And what I did is this allowed for me to have a comparison to where I could see how efficient the model was running with a certain amount of points compared to others. And that provided the ability for me to actually have a discussion and results I could look at. So what does this actually look like for Kenya? In this case, I took those bioclimatic variables, I took that information, and I took those mosquito locations, and it provided me to be able to analyze specific locations where we would expect to have a high similarity to outbreak, as well as identifying locations where we also have low confidence in outbreak locations. So what I could do is I could be able to compare all these different locations, but the key is being able to have those individual iterations compared to the points and locations with the actual averages map. And so in this case, with the individual iterations and having 195 million points of analysis, I get a much more detailed analysis and identification of the key risk factors, as well as being able to identify where, with limited resources, we can man and position our individuals. So let me take a step back and identify that with this presentation, I'm going to talk about two statistical tools. The first one was Similarity Search, but the second one here is talking about our ArcGIS predictive analysis tools. And this tool set is a free add-in that provides the ability to look at suitable locations, provides an iterative or detective-like workflow so we can be able to analyze information. We can also be able to pull historic information to look and provide to see if there's key characteristics or key information that make it accessible, as well as it provides a means to where we can share and repeat this workflow really quickly and easily, as well as collaborate and share this information efficiently. So let me talk a little bit too about the versatility of this tool set. Not only can this be tailored towards medical and health, but it can also be tailored towards other types of analyses as well. With defense and intel, it can be looked at finding enemy targets. With law enforcement, they use it for looking at drug interdiction. With geodesign, they look at urban planning, identifying areas and locations that will benefit from having, looking at the predictability of where that location will be. And then with weather, we can be able to predict future heat waves or other types of generic things by using this tool set. So this tool set has two main components. The first is looking at the pattern of life or the doctrine, to where we can define a question, build our query, predict that information, and then analyze that information, but also have the ability to refine it. So the key with this tool set is not only being able to say, like, this for sure is the key thing that we need to do, but being able to take those results, take that hypothesis, and test and go through it multiple times. At the same time, we can also use point information. So maybe we have previous outbreaks or locations where a disease occurred. And what we can do is we can be able to identify those key outbreaks in those key locations, use suitability of other types of environmental constraints based off of maybe published literature, and be able to put all this stuff together into a map to where we can refine this information. But the key thing with this type of analysis is that it's not just defining the information from a geographer, but I can create my analysis, be able to share this with an epidemiologist, incorporate information maybe from an entomologist, and be able to create this process where we're going back and forth and refining each other's analyses. So with this analysis, what we can do is we can also be able to have the statistics underneath based off of the published literature, identifying locations where we have the confidence intervals with our data and information. And at the same time, it can give us the ability, in this case, analyzing suitability for dengue in Africa, looking at a number of different point densities, information based off of temperature, precipitation, and habitat, and providing that more localized analysis at a 1 kilometer by 1 kilometer resolution. And one thing we can do too is be able to test this model with the point information by analyzing how well this model compared to the other iterations of it as well. So let me kind of show this as well. One thing we can do too is being able to identify, based off of this model, I can take global data sets of information. I can be able to use the information from published literature on the habitat for Aedes species, as well as being able to draw in information on precipitation, temperature, and elevation constraints for this information. And in a matter of minutes, I can be able to analyze this information, but also to be able to incorporate the published literature and that information to give me my results on a map. This can be used as just like a quick detection and a quick identification of those key areas, which can be more refined as additional information, additional data is made available. But rather than me just tell you about this, I thought it'd be more beneficial if I just show you an example of a dissemination product that we could use. So this is an example of a map journal. And with this map journal, I can be able to pull together information from an epidemiologist. I could pull into information from the CDC, from PAHO, from other sources of data and information to allow for someone to interrogate how this virus actually works. I can be able to incorporate information made available through CDC, through PAHO publications, through the World Health Organization, as well as being able to provide maps, media, information, images, as well as live maps that I can interrogate and be able to pull information on the habitat and when this survey was actually collected. At the same time, I can also incorporate information, in this case from the CDC, looking at the approximate distribution of the Aedes and Aedes aegypti mosquitoes, as well as pulling in historical information, images, and then looking at the U.S. to identify key locations and having smart pop-ups to enable those that maybe are seeking and identifying this information for the first time. So with that, I just want to close and say thank you for this opportunity. Thank you for the ability to be here and present, and thank you for your time. Are there any questions? Yes.
Just an observation as to the ability with which you can provide those information is still rate limited by, is it not, by the finding that information in the first place. So all of the Aedes data that were shown on there have been collated and made available in another format which you can bring together.
Yeah, I can't really hear. Well,
So all the Aedes data that you showed there have been put together globally and made freely available so that people can use them.
Exactly.
But saying that you can do that all in minutes is predicated on that year of work that put that together in the first place. So I wouldn't want to leave people with a false impression that you can just go to another disease and find all that vector data just sitting around.
Definitely.
So I'm wondering what your perspective is on that side of things, and how we can move to make those make inroads into that the big chunks of data which are missing in this space.
Definitely. I know that one way I think that we can definitely make that is by pulling together, the work that Professor Hay and his team has been doing in pulling together all these data and information. I think that there should be a repository, or there should be the ability for us to be able to utilize open data and other types of initiatives to be able to have that information, or essentially almost like a library or a dictionary of that information that then we can be able to share and collaborate with. I also think too it's beneficial to not only have geographers working together, but to incorporate the methodologies, the doctrines from epidemiologists, as well as the entomologists who have that key knowledge of the specific, in this case, environmental constraints and other types of things like that as well. If a geographer puts together a map and says this is the end-all be-all, he's lying to himself, because he's not really pulling together all that key information from those other disciplines. Other questions?
So I like the map journal format that ESRI has quite a bit, but I think this would be another place, because every one of those maps is pulling data from something else. We're having some kind of citation, or this map is based on these data. It could be buried in the text, but people are going to cut and paste these pictures and put them in news reports and so on, as long as that can be incorporated in the display. And I do know that's an area of development, but I think it's something a group like this, we want to have a layer like this on top of the publicly available data, but we also want to be able to track back where it comes from.
Definitely. Thank you.
Thank you, and thank you, David. That was fascinating. Let me move on to